Hey guys, welcome back to the channel. Today we're going to be solving LeetCode 162, find peak element. Keep in mind we solved this problem before using this method and the solution worked fine. As far as performance, it wasn't bad at all. But today I want to solve it in different ways. The reason is in this solution, again, it's not bad, but we were moving our pointers one at a time. So we'll move our left by one, we'll move our right by one, move by one, okay, based on the case. So is there a way we can move by multiple indices? And yes, there is. And I'm going to explain that to you. This new solution is pretty similar, but let's just see the slight difference. Okay, so as always we have our left and right pointer that stays standard. Okay, but now in our while loop we're going to do something else. We're going to create a middle pointer, mid. Okay, and he's equal to our right plus our left, integer divide by 2. So now we're the middle. Now we have a middle guy. Okay, so next we're gonna say if this middle guy, okay, if nums of this middle guy, okay, if he's less than nums of the guy that's next to him, if he's less, okay, than the guy that's next to him, what do we want to do? We want to move our left pointer because we don't care about everybody else, and I'm going to explain to you guys so you guys can visualize it. So we want to move our left pointer to mid plus 1. Else, meaning the reverse is the case, we want to move our right pointer, and let's move him to mid, not mid plus 1. And then in the end, okay, we want to return. Once we're done with this, we just want to return mid. Okay, this is, I think, should be quicker, but let's go ahead and run the code first. Okay, accepted. Let's go ahead and submit it. So this is an issue. Let's try returning L instead. Okay, let's see what that does. Okay, bam. Okay, so yeah, this works. Okay, we're returning L. And now let me show you guys why this works. Again, we're gonna use the same run. We're gonna use the same example we used before. So in this case, here's what we're doing. Okay, we simply have the exact same array. Okay, I'm gonna wipe all those guys off because we don't really need these guys right now. So here's what we're doing. Just like before, we initialized our left and our right pointers. But then again, we calculated a guy called mid, and mid was just, I'm just gonna say m, was just equal to left plus right, which is 6 plus 0 divided by 2, in this case 3. Okay, so our mid, which I'm just gonna call m for simplicity, is right here. Okay, so in the first iteration, what do? We're saying if nums, we're comparing nums of mid is 3. Is he less, okay, is he less than the guy who's next to him, which is nums of mid plus 1, which is this guy, nums of mid plus 1. Okay, it's 5. Is 3 less than 5? Okay, the answer is yes. Okay, since it's yes, what we want to do, we want to move our left pointer. So left is going to be equal to mid plus 1. So that's essentially, we're moving our left from here to mid plus 1 right here. This is our new left pointer. Okay, so what this essentially does is cancels this part of the array. We don't need to search it, we don't need to look at it anymore. So again, we're going to calculate our new mid. Okay, what is our new mid? M equals to left plus right, so in this case left is now 4, index 4, plus 6 divided by 2, which is 5. 4 plus 6 is 10, yeah, 5. Okay, so now our new mid is index 5. So we're done with our previous mid. Okay, so now we want to ask the same question again. Okay, is mid is 6. Is he less than, okay, is he less than mid plus 1, which is 4? Okay, because mid plus 1 also happens to be our right pointer. Okay, is he less than 4? This is no, this is a false. So in this case, if it's a false, what do we want? We want to move our right moves to our mid. So essentially what that does is, so this becomes our right. What that does is cancels out this guy. So once we do that, then we want to, in this case, we want to check our while loop again. And if we check our while loop, is L still less than R? Yeah, he is. Okay, now we do it one more time. Okay, if we calculate our mid again, our new mid in this case, once we recalculate our mid is going to be 5 plus 4. Okay, this is 5 divided by 2. 5 plus 4 is what? 9 divided by 2. Again, is a floor divide, so integer divide. So that's going to give us 8 divided by 2. It's just going to give us 4, right? Okay, so now our mid is now moves from this point. So that is just our right pointer now. Our mid is the same as our left pointer. Okay, so then we ask the question, is mid, okay, mid is 5, okay, is he less than mid plus 1, which is 6, okay, because this is now mid plus 1. Okay, is he less than 6? Answer is yes. So what do we want to do? We want to move our left pointer. Okay, let me show you. We want to move our left to mid plus 1. Okay, so we're going to move our left. So in this case, our left comes here. Our left is now our right, and this is going to cause our while loop to break, because now the while L and R are now equal, and we just return our left, and our left happens to be 5, so we return. Okay, so that's it for the video, guys. I hope this was helpful in showing you guys at least this problem, and I'll see you guys on the next one.